the red probe here in the positive terminal and the black probe in the negative terminal, we should get in the multimeter increase and decrease value. As you can see, you see, means the capacitor charge and discharge, means this is a good capacitor. Now, how can I check this MOSFET? Basically, I should check between drain and source. Okay, so I will put the red probe here in the drain and the black probe here. The same working principle as normal MOSFET. I don't get here a reading. So let's swap the probe. I should get right now a reading. Okay, 400 drop voltage. Means this is a good MOSFET. Here we have the power jack. Okay, so basically this is the power jack. Okay, here we have the power jack. Then we have the MOSFET here. So 19 volt, as you can see, goes from here to the source. Here we have the source of this MOSFET. This is basically a 3-terminal MOSFET. So here let's do like this. Here we have source and here we have drain, and this is the gates. Here we have gates. Okay, so and over here we have the diode. As you can see, this is the diode connected to the ground here. MOSFETs, inductor, capacitor. So we have two MOSFETs, we have inductor, we have capacitor. So the same here, we have inductor, we have two MOSFETs, we have capacitor. Inductor, MOSFETs, capacitor. Inductor, MOSFET, capacitor. Here also, as you can see here, we have inductor, MOSFETs. Let's go here. We don't have here capacitor. So let's see where is the capacitor here. We have the capacitor. As you can see, the capacitor is removed over here. So the capacitor is removed here. As you can see, we have the negative terminal and the positive terminal. So exactly as we have here, we have the negative terminal and the positive terminal. Okay, this is here the input of the motherboard. So the power goes here, the 19 volt goes here, and then pass through this diode. This is protection diode, and then pass through this MOSFETs, and then through this MOSFETs, and then goes directly until here. Here we have, as you can see, the current sense resistor. So the power, the 19 volt, will be distributed here to the whole motherboard. It will be distributed from here to the CPU, to the graphic card, and to the ICH, to the RAM, so to the whole motherboard. Okay, so this is the input. So basically here we have two inductors. So here this is for the power jack. Here we have the input, but these two inductors with this MOSFETs, as you can see here, and with these three capacitors, this is basically, this circuit is 3 volt 5 volt circuit. So these inductors, as you can see here, okay, with these two MOSFETs and this capacitor is for 3 volt channel. Then this inductor with these two MOSFETs and this capacitor is for 5 volt channel. Okay, but where is the IC here? Where is the IC? So let's go to the back and look for the IC. Here we have the IC. So this is the 3 volt 5 volt control IC. Okay, and here we have, as you can see, the first channel where we have inductor, MOSFET, capacitor. The second channel, inductor, MOSFET, capacitor. So let's begin with this inductor. Nothing. This one, we get a reading. So let's check this one also. Here, nothing. Here, we get a reading. Let's check this one. Here. Oh, here we get a low resistance. But please pay attention. This channel is for the CPU. So this low resistance that we get here could be the resistance for the CPU. So let's remove the CPU and check again. So let's remove the CPU. So now I remove the CPU. So let's check again this inductor. Do you see a high reading in the multimeter? Okay, if I put back the CPU, so let's put back the CPU. So let's check again. A low resistance again. So please pay attention to this point. This is not a short circuit. This is the resistance for the CPU, because the CPU has a very low resistance, as you can see. a very low resistance. So once I remove the CPU, so I will put the probe here, as you can see, and remove the CPU in the same time. Do you see? Now I open the CPU, the resistance is increased. Let's close this nut. Do you see? Open, the resistance increase, close, open, close. This means that the reading that we get here is not a short circuit. This is the resistance for the CPU. So let's check other inductors, for example, this inductor. Here we have a short circuit. Hi. In this video, I'm going to teach you how to fix a dead laptop motherboard using the multimeter. In the same time, I'm going to use the schematic, as you can see here, in order to make things easier for you. And of course, I'm going to teach you how to find and isolate the short circuit in the motherboard. So let's get started. So we're gonna study in this video, as you can see, this motherboard, but the same working principle for all motherboards. So basically this motherboard is for HP Compact G62. Okay, so this is HP Compact G62 motherboard. This is a failed motherboard. This is the motherboard that we're gonna study. Okay, but if you understand just the working principle, you can fix any other motherboards. Okay, so let's get started. But please don't forget to subscribe, share and like the video, because your likes motivate me to create more videos for you. Thank you very much. So when you get any motherboard, as you can see, like this motherboard, the first thing is the visual inspection, because sometimes just using the visual inspection you can detect the failed components. Okay, so we're gonna begin here. For example, this is the input of the voltage. Here we have the power jack connector. So let's do a visual inspection over here and look for any failed component. So here the components are good. Okay, we have here the RAM slots. So basically this is the RAM slot circuit over here, and then we have the processor. So this is basically the processor circuit, as you can see here. Okay, so all these MOSFETs are good. Then let's move on to the graphic card. Here we have the graphic card. So it seems that this graphic card is already repaired. As you can see here, we have a little bit flax. Okay, and then we can go here, as you can see, to the ICH. This is the ICH, okay, or the circuit bridge. So all seems to be good. Here we have the IC, the control IC, and here we have the ICH circuit. As you can see, we have two MOSFETs, we have inductor. Always when you find two MOSFETs and inductor, means this is a circuit. So here we have the ICH circuit over here. Okay, so here we have the CPU circuit, as you can see here. We have inductors here, we have MOSFETs here. So here basically this is the RAM circuit, as you can see. This is the RAM circuit, where we have two MOSFETs, inductor, capacitor. So always any circuit you will find MOSFETs, inductor, capacitor, as you can see here. If we go to the schematic, for example here for the schematic, so we have two MOSFETs, we have inductor, we have capacitor, as you can see. Okay, so in order to get 1.8 volt for RAM, so we have always the IC, the control IC. Then we should get two MOSFETs, inductor, the reference of inductor is L, electrolytic capacitor, and then of course the pad, the test point, and then we will get this voltage. The same, for example, for this circuit over here, where we have 1.5 volts for ICH and mode bridge. So we have two MOSFETs, we have inductor L5, we have electrolytic capacitor, and of course the control IC. So always the same working principle. Okay, so the same here, we have inductor, we have two MOSFETs, we have capacitor. Inductor, MOSFETs, capacitor. Okay, so inductor, MOSFET, capacitor. Here also, as you can see here, we have inductor, MOSFETs. Let's go here. We don't have here capacitor, so let's see where is the capacitor here. We have the capacitor. As you can see, the capacitor is removed over here. So the capacitor is removed here. As you can see, we have the negative terminal and the positive terminal. So exactly as we have here for this capacitor, we have the negative terminal and the positive terminal. Okay, so the capacitor is removed here for this circuit. So the capacitor is missing, but we're gonna check step by step how to diagnose this motherboard and how to find any short circuit if you have a short circuit. Okay, so but first let's see the other side and do a visual inspection. So here basically this could be the charge IC. Here we have another IC. This is basically the CPU input output here. Okay, so here as you can see we have flux. This motherboard is already repaired. Okay, so here this tantalum capacitor is for the processor. Okay, so this motherboard seems good. Here we have other two MOSFETs. Basically this is another circuit. So this circuit basically contains these two MOSFETs here, inductor, capacitor, and another two MOSFET. So this circuit generates the voltage, the working voltage for these chipsets. Okay, now we're gonna use the multimeter. So what should we do right now? So here we have the motherboard, as you can see. This is here the input of the motherboard. So the power goes here, the 19 volt goes here, and then pass through this diode. This is protection diode, and then pass through this MOSFETs. Okay, and then this electrolytic capacitor. So and then through this MOSFETs, and then goes directly until here. Here we have, as you can see, the current sense resistor. So the power, the 19 volt, will be distributed here to the whole motherboard. It will be distributed from here to the CPU, to the graphic card, and to the ICH, to the RAM, so to the whole motherboard. Okay, so this is the input. So basically here we have two inductors. So here this is for the power jack. Here we have the input. Okay, but these two inductors with this MOSFETs, as you can see here, and with these three capacitors, this is basically this circuit is 3 volt 5 volt circuit. Okay, we have basically two inductors. So these inductors, as you can see here, okay, with these two MOSFETs, and this capacitor is for 3 volt channel. Then this inductor with these two MOSFETs and this capacitor is for 5 volt channel. Okay, but where is the IC here? Where is the IC? So let's go to the back and look for the IC. Here we have the IC. So this is the 3 volt 5 volt control IC. Okay, and here we have, as you can see, the first channel where we have inductor, MOSFETs, capacitor. The second channel, inductor, MOSFETs, capacitor. So let's look the schematic. As you can see here in the schematic, we have the IC. This is the IC. Let's find the IC. We have here the IC, as you can see. Okay. Okay. Good. Then here for 5 volts, always we have two MOSFETs, inductor, electrolytic capacitor. So two MOSFETs, inductor, electrolytic capacitor. And for 5 volts we have two MOSFETs, inductor, electrolytic capacitor. So two MOSFETs, inductor, electrolytic capacitor. Okay, so here as you can see, so this IC will control these two MOSFETs. Okay, in order to generate this voltage 5 volt. The voltage will pass through inductor in order to adjust the voltage. It increases basically the current. Okay, and then we have here the electrolytic capacitor that will filter the current in order to get a continuous voltage. Okay, so the same here. So we have the 19 volt, the main voltage will pass through this MOSFETs, and then here we will get 3 volts after receiving the control signal from this IC, and then the voltage will pass through the inductor in order to increase the current and adjust the current, and then through this electrolytic capacitor in order to filter the current, and then we will get 3 volts. Okay, now I hope that you understand the 3 volt 5 volt circuit in the motherboard. So as you can see here, we have two MOSFETs, inductor will increase the current, and the capacitor, these capacitors will filter the current, and then we will get here we will get 3 volt, here we will get 5 volt. Okay, so this is the input voltage. So let's make some tests. Let's use the multimeter and check this first component here. So basically this component here are very important. If you have a dead motherboard or a failed motherboard, you should always begin with the components in the input. We're gonna check this component, the diode, the MOSFET, the capacitors, the inductor also, and this MOSFETs. And we're gonna confirm if we have a shorted component here or not. So let's use the multimeter. So of course I'm going to choose in the multimeter the diode option and then press the power button. Okay, let's check the continuity. Okay, you see the multimeter here, we have the continuity. So first let's check this diode. Basically this diode is connected to the ground in one side and to the main to the 19 volt power in other side, because this is protection diode. Okay, so let's check first the diode, is it good or not. So here we have the cathode, so the black probe, so the black probe of the multimeter, as you can see, in the cathode. Okay, and the red probe in the anode. So let's check, we get a reading. So this is a good diode, I get about 600 drop voltage. Okay, so if I swap the probes, so let's swap the probes, we should get nothing in the middle. Good, this is a good diode. So this kind of a diode, basically one side is connected to the ground and the other side should be connected to the power rail. Okay, to the 19 volt power. So let's check, for example, this side here. As you can see, so this side is connected to the ground. So this side should be connected here to the power rail. So let's check this side here to this terminal. Now let's check with this MOSFET. Yes, it is connected to this MOSFET, to the drain of this MOSFET. So the source should be connected to this part. Good. This is good. So I will draw for you the schematic of this motherboard here. So here we have the power jack. Okay, so basically this is the power jack. Okay, here we have the power jack. Then we have the MOSFET here. So 19 volt, as you can see, goes from here to the source. Here we have the source of this MOSFET. This is basically a 3-terminal MOSFET. So here let's do like this. Here we have source and here we have drain, and this is the gates. Here we have gates. Okay, so and over here we have the diode. As you can see, this is the diode connected to the ground here. Okay, so if I check between this point and this point, so this point here, as you can see, is here, these 2 pins, and this point means the source. This is the source. So let's check. So I will check between the power jack and the source like this. Okay, so let's check. So here I have the 19 volt, because here we have this point, this dot here means this is 19 volt. So this is the power jack, and here we have the source, as you can see. Okay, so the power jack is connected directly to the source of this MOSFET. So here to here. Then, so this point to this point here. Okay, now we're gonna check between the drain of the MOSFET. Here we have the drain of this MOSFET, as you can see here. This is the drain, and the cathode of this diode. Here we have the cathode. You see this mark means the cathode. So let's check. We should find a continuity between drain, okay, and the cathode of the diode. So if we check here, we should find about 0 reading. Okay, in the multimeter. So let's check. Here we have the drain. Okay, and this is the cathode. Do you see in the multimeter? Good. So here also good. So now this part between the power jack, the source, the drain, and the anode, this part is good. And then, as you can see, if I check between the anode and the ground, as you can see, I should find a reading here. Okay, so here we have the anode here of diode, and we have the ground. As you can see, we get a reading. So this is basically, this diode is used for what? This diode is used for protection. It's used for protection. Okay? If this diode is shorted, you will find a short circuit here. You will find this diode shorted. But for us, this diode is not shorted. This diode is good one. As you can see, we get a reading in the multimeter. Good diode. So let's check other component here, including this MOSFET, this capacitor, these two inductors, this tantalum capacitor, and also this MOSFET and this MOSFET also. So here the inductor basically should give a reading. This is good inductor because the inductor is just a wire. So here we have another inductor. So let's check this inductor. This is also a good inductor. Here let's check basically these two capacitors. Here we have positive terminal and here negative. Always this mark here means negative terminal. This also negative. So let's check this one and this one. Okay, do you see? Charge and discharge. So some of you will ask me, can we check the capacitor in the continuity mode? Yes, you can. So if you check the capacitor in the continuity mode, just put the positive terminal here in the positive terminal and the negative terminal in the negative terminal. You should get in the multimeter increasing and decreasing value. Means the capacitor charge and discharge. Means the capacitor is good. Okay? If you get a continuity, means the capacitor is failed. So let's check. So the red probe here in the positive terminal and the black probe in the negative terminal, we should get in the multimeter increase and decrease value. As you can see. Do you see? Means the capacitor charge and discharge. Means this is a good capacitor. Let's check this one also. So here we have plus, as you can see. So the red probe here and the black probe over here. Okay? Good capacitor. This one also is check. Also good capacitor. Okay? So for the MOSFET, basically the MOSFET, the 8 pin MOSFET has 4 pins for drain, 3 pins for source, and the 4th pin is for gate. So I will show in the schematic. Here, for example, as you can see, we have a MOSFET. So this is the drain of this MOSFET. We have here D. So 4 pins connected together. Here we have S. 3 pins source, 3 pins connected together, and the 4th pin always is for gate. So the first pin, second and 3 is for source. The 4th pin is gate, and pin number 5, 6, 7, 8 is for drain. So let's check in the motherboard. So let's take, for example, this MOSFET here. So we have here this white dot, means this is the first pin. 1, 2, 3. Means these 3 are source. 3 should be connected together. So let's check. So this is the first pin, should be connected to the second one. As you can see, to the third one. As you can see. Okay, so 3 pins connected together. But here with the gate, as you can see, now continue it. Okay, and here we have, as you can see, this is the gate, and here these 4 pins are for drain. Let's check these 4 pins should be connected together. So let's check this pin, as you can see, should be connected to this pin. should be connected to this pin also and to this pin also, as you can see. Okay, this is good. Now, how can I check this MOSFET? Basically, a short check between drain and source. Okay, so I will put the red probe here in the drain and the black probe here. The same working principle as normal MOSFET. I don't get here a reading. Okay, I don't get a reading. So let's swap the probe. I should get right now a reading. Okay, 400 drop voltage. Means this is a good MOSFET. This is a good MOSFET. Let's check this one also. So between drain, between source and drain, because here we have the white dot. So source and drain, we get a reading. If I swap the probes, I should not get any reading, as you can see. No reading in the multimeter. Okay, so this is how we can check MOSFETs. So for this capacitor, the same working principle as this one. This is basically a tantalum capacitor. Here we have plus and here we have minus. So this is not a diode, this is tantalum capacitor. So let's check this tantalum capacitor. Here we have positive terminal and here we have negative terminal. Do you see? The value increase and decrease. Okay? Means this capacitor is good also. So when you get a continuity like this, okay, and a buzzer, while testing this kind of capacitor and this kind of capacitor, and even this kind of capacitor, ceramic capacitors, okay, means the capacitor is bad, is shorted. But if you get increased value and decreased value, like this in the multimeter, means the capacitor is good. So basically, how to test? In order to check this current sense resistor, we should get a reading, because this is a very low resistance, a value. This is just like a fuse. So this is good, because this is current sense resistor. Okay, it's like a fuse. So the purpose of this current sense resistor is to control the current. It senses its current sense resistor, it senses the current and verify whether the current is enough for the circuit or not. Okay, so this is basically how you can check the charge circuit and the 3 volt 5 volt circuit. You can use the same working principle for all circuits in the motherboards. Okay, now let me teach you how to identify a short circuit. So to identify a short circuit, I will give you a trick. You know that, okay, the inductor, as you can see here, in every laptop, always you will find inductors connected to the power rail, as you can see. So this inductor is connected to the power rail. You can never find inductor connected to the ground. This inductor also connected to the power rail. Okay, so if we go to another page, for example, here we have another inductor here connected to the power rail, 1.5 volt power rail. This inductor also connected to the power rail. So always inductors are connected to the power rail, as you can see. Inductor connected to the power rail, as you can see. But it cannot be connected to the ground. So we're gonna use this trick. The inductor, we're gonna check the inductor in the motherboard. If you find any inductor that is connected to the ground, means the short circuit is around that inductor. For example, if we find that this inductor is connected to the ground, means somewhere here we have short circuit. It could be the MOSFET, it could be the capacitor, etc. Okay. So now, in order to look for the short circuit, you should always choose in the multimeter the continuity mode. Okay. So the black probe, you should always put it in the ground. Here, for example, we have the ground. Here we have the ground. Here we have the ground. Here we have the ground. Okay. Everywhere in the motherboard we have ground. Okay. Also here, this is ground. So I will, for example, put it here. Okay, this is ground here. So if I check between this, for example, and this, as you can see in the multimeter, we have low resistance. Okay, mean all this, as you can see, are ground, as you can see in the multimeter. Now I will check all inductors in the motherboards. If I find a low resistance here, means the short. For example, if I find here a low resistance and I get a buzzer, means the short circuit here. But if I find, for example, this inductor, a buzzer here, or a low resistance while testing this one, means the short circuit here. Okay, so let's begin with this inductor. Nothing. This one, we get a reading. So we get a reading, a high reading. So let's check this one also. Here, nothing. Here, we get a reading. Let's check this one. Here. Oh, here we get a low resistance. But please pay attention. This channel is for the CPU. So this low resistance that we get here could be the resistance for the CPU. So let's remove the CPU and check again. So let's remove the CPU like this. Okay, the CPU is removed. As you can see, to remove the CPU, as you can see here, so we have here, this means closed, this means open. Okay, now the CPU is open. So now I remove the CPU. So let's check again this inductor. So let's check. Do you see a high reading in the multimeter? Okay, if I put back the CPU, so let's put back the CPU. Okay, so let's close this. Okay, the CPU now is in. So let's check again. A low resistance again. Do you see? So for these two inductors, you see, low resistance, low resistance. Do you see? Low resistance. So please pay attention to this point. This is not a short circuit. This is the resistance for the CPU, because the CPU has a very low resistance, as you can see, a very low resistance. So once I remove the CPU, so I will put the probe here, as you can see, and remove the CPU in the same time. Do you see? Now I open the CPU, the resistance is increased. Let's close this nut. Do you see? Open, the resistance increase, close, open, close. So means, this means that the reading that we get here is not a short circuit. This is the resistance for the CPU. So please pay attention to CPU. The same to CPU. Okay, so let's check other inductors. For example, this inductor. Oh, here we have a short circuit. Guys, here we have a short circuit. So this is a low reading. This is not the resistance for the ICH. This is a very low reading. So this is a very low reading. This is not the resistance for the ICH. This is a very low reading. So here we have a short circuit. So let's check the capacitors, ceramic capacitors in this circuit. For example, this one. Do you see? Do you see in the multimeter? Here we have short circuit. Here we have short circuit. Okay, here we have short circuit, guys. So using just the inductor, we identify the short circuit, and the motherboard. So that's it for this video, guys. I will continue in other videos. Thank you very much. I hope that you enjoyed the video. Please don't forget to subscribe, share, and like. You know, your likes and engagement motivate me, really motivate me to create more and more videos for you. Thank you very much, and see you in the next video. And of course, for anyone who wants to join me in the Patreon page, you are very welcome. Thank you very much.